Hi, traveling waves was the subject of this week's episode of Crash Course Physics. And here, there's not a lot to nitpick here, almost nothing, but I want to complement the contents of this episode with a little explanation of why we model so much with springs. So in the episode, the longitudinal waves have been illustrated with waves traveling along a spring, and in last week's nitpicks I talked about how the interactions between atoms can be modeled with little springs. So imagine a string of atoms, each bound by a chemical bond to its two neighbors. Then the chemical bond is a force that depends on the distance between the two atoms, and it typically looks like this. The atoms are slightly attractive if they are further apart, and very repulsive to each other when they are pushed closer together. And in the middle there's an equilibrium point where the force between the atoms is zero. Now, at this equilibrium point, we can model the force law by a linear function, by taking the derivative of the actual force function. And as long as we don't move too far away from the equilibrium point, the force law looks a bit like this. So minus a spring constant times the difference between the position and the equilibrium point. So this force law, of course, is the law that governs a spring, so we can imagine, for many practical purposes, the interactions between atoms as springs. In 3 dimensions, of course, this becomes a whole lattice, and we can imagine a wave traveling through a medium, sort of like collective behavior illustrated in this picture to the right. Now, this behavior explains both transverse oscillations and longitudinal waves. What else? Oh yes, before I forgot. Really? Anyway, so that was all for this week's episode, and don't forget to subscribe, and yeah, see you next time.